This is from 2011. Next. Simple question. Which of the following functions is differentiable everywhere? Okay. Now for our convenience, let us choose a at 0. Okay, let us choose a at 0. So option A becomes mod x upon x. Right, option A becomes mod x upon x. So we know what this function is. This function is not defined at 0. Now everywhere, I understand by everywhere we mean for all real numbers. Okay, so not defined at 0, so no question of that being differentiable. Okay, so well, in everywhere I mean for all x in the set of real numbers. Okay, let's go to B. It is x into mod x, right? B is x into mod x. What is C? X plus mod x. Now look, x plus mod x is not differentiable at 0, so C is also not right. Okay, so A gone, C gone. Let's come to D. I know B is right, but I just want to see whether x raised to mod of x raised to 1 upon 3, rather mod x raised to 1 upon 3 is right. Now see, even this can't be differentiable because inner function is mod x, so it is not, well, it is bound to be not differentiable at 0. But let's dig deeper. Okay, let's consider x raised to 1 upon 3, and try to find its derivative. 1 upon 3 into x raised to negative 2 by 3. Right there you understood that it's in the denominator. X is in the denominator. Okay, x is in the denominator. Okay, not square root but cube root. Right, so at 0 it won't be differentiable. So which option is correct? B is right. And we know how that behaves, right? Option B. It will be y equal to x squared in the first quadrant, and it will be y equal to negative x squared in the third quadrant, pretty much like y equal to x cube. Okay, so which option is correct? C gone, B is right, D is also not. Now always keep this habit of checking your answer whenever possible. Okay, now let us come to the grapher and see. Okay, first let's go for mod x by x. It's not different, it's discontinuous at 0, so no question of being differentiable. X into mod x, that's true, it is differentiable there because the way closer we go to 0, the curve becomes flatter and flatter, right? Okay, what other options did we have? X plus mod x, you know, that's that red one, it is 0 for negative values, and mod x raised to 1 upon 3. Okay, this is the derivative. Okay, this is the function, and you can see that it is forming, when we give it a specific name, that part in this particular situation, okay, we call it a cusp. Okay, this is CUSP, cusp at 0. Okay, that's actually a cusp at 0. Okay, but again, you know, it's not differentiable because the tangent is vertical. Okay, tangent is vertical, so option is x mod x. Okay, and that also tells you something. Okay, what does it tell you? Although in f into g, g may not be differentiable, or even if g is not differentiable, f into g may be differentiable. Got it? That is something that we can learn from this problem, that it need not always be true that for the product to be differentiable, the individual functions should be differentiable. We have seen that it doesn't necessarily it's not necessarily true that both functions should be differentiable for the product to be differentiable. Got it?